Welcome back to our channel, guys. So let's continue our quarterly test preparation today. So in my previous video, I had covered a few MCQs and fill in the blanks along with that 5 markers. So today I'll be continuing with that video. Okay. So this is a part 2. And yeah, so last class, I had done one small error, okay, in one of the MCQs. So that I would like to, yeah. So in this question, like in projectile motion at the highest point, so at the highest point, the vertical component will be 0, students. Where I had mentioned horizontal component of velocity is 0. Sorry for that. Because the vertical component is 0, whereas horizontal component of the velocity will be constant. So at the highest point of projectile motion, please note this. Fine. So today we will continue with our 5 markers. So in my previous video, I had covered all these questions. In case if you had not gone through, please go through that. It will be really helpful for your quarterly preparation. Okay, fine. So now we'll move to the next question. That's Newton's third law. Okay, so practice all the Newton's first, second, and third law. It can be asked for a 2 markers, 3 markers, or if for a 5 markers. I mean, they might ask you as a derivation along with the statement. Okay, so first Newton's second law. So what does Newton's second law states? It's basically the rate of change of momentum is directly proportional to force, right? Also, we can say the force is a product of mass and acceleration, where we know the formula F equals ma. So here we will have to prove F equals ma, students. So for that, let me take a force formula. Okay, as per the statement, F is directly proportional to the rate of change of momentum. You can take delta P by delta T, or you can take a differentiation dP by dt. Where P is what? P is nothing but product of mass and velocity. Okay, so P is product of mass and velocity. You can substitute that over here. So d by dt of P is what? Mass times velocity. Now, force is directly proportional, or you can just put in place of proportionality, you can put a constant k. Since mass is constant, keep it outside the differentiation. So you will get dV by dt. Okay. So now, in case if you want to take k as 1, like a proportionality constant, you can take it as 1, and then mass. So dV by dt is what? The rate of change of velocity, right? So the rate of change of velocity is acceleration. So hence F equals m times a, or 1 into ma is nothing but F equals m times a. Hence proved. Okay, it's a very small step derivation. Most expect they might ask you for a 3 markers. So please remember, but it's one of the important questions. Fine. Now let's move to the next question. State and prove law of conservation of linear momentum in case of the collision of two bodies. Okay. So yeah, even this is one of the expected. So first state the law. Okay. So mainly, what is the meaning of conservation? Okay, you would have learned conservation of energy, conservation of mass in chemistry, right? So conservation is something like where in case if you are taking conservation of energy, energy can neither be created nor destroyed. Similarly, conservation of momentum is something momentum can neither be created nor destroyed. Okay, so the total momentum remains constant. So here we will be taking the collision of two bodies. Okay, I'll name those two bodies as I'll just take two bodies, the one body A and the other object as B. Okay, so this is going with some momentum PA and PB. Okay, so this is a initially. After collision, of course, its velocity changes, right? That's the reason the momentum also changes to PA dash or PA prime. So PA becomes PA, this is after collision. Similarly, the object body velocity also changes and its momentum changes to PB dash. Okay, so this is the after collision. Now we will have to prove that the momentum before collision will be equal to momentum after collision. Okay, so for that now what we can do here is we'll just take the change in momentum of a body. Okay, so the change in the change in momentum of object A or of object A. Okay, so can be taken as, so what's the change in momentum, students? So before collision it was PA, after collision it has changed to PA dash. So can we write the change in momentum as PA dash minus PA? Yes, we can write, no? Similarly, we can write the change in momentum of body B as, okay, so the change in momentum of object B equals PB dash minus P. So this is a change in the momentum. Also, we have learned in my previous derivation I had taken the rate of change of momentum is directly proportional to force, right? F is directly proportional to rate of change of momentum. Now, I have taken a change of momentum. See, change of momentum we write as in the form of a differentiation. Okay. So now, can we write this change of momentum as force into dt? Yes, we can write no, since dp is what? Pa dash minus pb, which is equal to force acting on A with respect to B will be taken as FAB and dt. Similarly, I'll write this one as FP, FBA times dt. Okay, just from the Newton's second law itself. So the change in momentum is force times the time. Now, from Newton's third law, okay, now I took second law over here. Now, from Newton's third law, we know that. So I hope you know what is Newton's third law. So the Newton's third law states that for every action there's equal and opposite reaction, right? Similarly, force acting on A with respect to B will be equal and opposite to force acting on B with respect to A, right? So now, what is FAB from the formula? We can write it as PA dash minus PA divided by dt equals minus of course it's equal and opposite, that's the reason we are using minus here. FBA can be written as PB dash minus PB divided by dt. Okay, now cancel dt and dt. So what will you get here? You will get PA dash minus PA equals minus of PB dash, minus into minus will be plus PA. Okay, so now I'll bring one second. PB, sorry, yeah, PB. Okay, so now I'll bring this minus PB dash over here. So I will be getting PA dash plus PB dash will be equal to PA plus PB. So hence, what did we prove here? We proved that the momentum before collision will be equal to momentum after collision. That you can write it as a closing statement. Hence, we are proving the conservation of linear momentum. So what is conservation of linear momentum states? The momentum of an object before collision will be equal to momentum of the body after the collisions. Okay. So hence prove, yeah, this, as I said, this is the one of the most expected 5 markers. Fine. Now moving to the next question. State and prove. Again, here they're asking you to prove the law of conservation of mechanical energy in case of a freely falling body. Yeah, it is one of the most simple derivation. So firstly, we should note that what is mechanical energy, students? So mechanical energy is what? Sum of potential energy and kinetic energy, right? Okay, sum of potential energy plus kinetic energy. So if we say that again, the law of conservation of mechanical energy means the mechanical energy can neither be created nor destroyed, or the total energy remains constant. So throughout the motion, so it is a freely falling body. So throughout the motion, we should prove that energy remains constant at every interval. So that's what we are going to prove it over here. So they're asking us to prove in case of a freely falling body. So now let me draw an object which is falling freely. Okay, so this is at a height h, let me take over here. This is at a height h and let me take this position as A and this position as B. Now, at position A, okay, at the position A, that's the highest point where object is thrown. Remember, at position A, always kinetic energy will be 0. Why? Because the initial velocity will be 0. That's the reason kinetic energy will be 0, whereas potential energy will be, okay, so potential energy of that object will be mass where gravity is acting and it is at a height h. Okay, so please remember this. At point A, at position A, kinetic energy will be 0, whereas potential energy will be mgh. Therefore, what is total energy or mechanical energy? Of course, it's a sum of potential and kinetic, right? So, potential energy plus kinetic energy. So potential energy is given as mgh, kinetic energy is 0, therefore it is mgh. Okay, so the total energy at position A will be mgh. So let me take this as equation 2. Now, at the position B, at the position B is at the ground level, students. I'm just taking a highest level and the ground level. You can take the intermediate also, but I'm just taking the extreme ones and the minimum ones. That's now on the ground level. Now, kinetic energy, of course, there is a velocity. We have kinetic energy. So, kinetic energy is given by a formula half mv square. Okay. What about potential energy? So, potential energy formula is what? mgh, right? Do we have any height at the ground level? Since height is 0, therefore potential energy is also a 0. In this case, U is 0, therefore kinetic energy is also 0. That's the reason. Now, kinetic energy is half mv square, potential energy is 0. My total energy will be half mv square. Of course, there is a difference in the equation, right? But what are we learning that? We are learning that the energy remains constant throughout. Throughout its motion, the energy remains constant, right? So that's the reason our derivation is not yet done. So now what we have to do is we have to just change this derivation. Okay. So now I will just take kinetic energy as, okay, kinetic energy, let me take it as half, yes, okay, m. Instead of v square, let me use the equation of motion. So equation of motion is what? From v square minus u square, we know that v square will be equal to u square plus 2as, right? Whereas this is a freely falling body, that's the reason A will be replaced by, we are going towards the gravity, so A will be replaced by g, and yes, s is nothing but height, so s is replaced by h. Okay, so instead of this, you can just take v square as, um, yeah, u square plus 2gh. Now, again over here, at the position B, uh, yeah, we are taking u as 0 and then we get 2gh. Okay, you can substitute this over here, 0 plus 2gh as 2gh. So finally, if I cancel 2 and 2, I'll get kinetic energy as mgh. Therefore, the total energy will be equal to potential plus kinetic, right? Where potential energy is 0 and kinetic energy, of course, I'm getting it as mgh. Therefore, 0 plus mgh will be equal to mgh. Okay, so this is my equation. So from equation 1 and 2, okay, from equation 1 and 2, we can say that the total energy remains constant. Can you see that 1 and 2 both are having mgh, right? So the total energy remains constant throughout the motion. So hence we are proving that the conservation, that mechanical energy is conserved even in case of a freely falling bodies. Just you have to show that both the equation have same mgh whereas mgh. Okay. Hence, yeah, hence we have proved this. Now moving to the next question. Yeah, derive an expression for magnitude and direction of resultant of two vectors acting at a point. Okay, so this is from a motion in a plane chapter. Again, it's a most important question. So now we'll have to take a two vectors. For that, we'll have to find the resultant of two vectors, right? So for that, let me take a two vectors. Okay, so yeah, I'll just take our two vectors. Okay, so I'll name this vector, I'll just denote it as O, and this is P, Q. 1 minute. Okay, I'll just name this as vector P, vector Q, and the resultant as vector R. Okay, so now let me join. I'm just taking a parallelogram over here. And let me join this and I'll name this as A, this as B, and this as C, this point C as C. Vector OA will be equal to P, vector OC is R, and vector OB is vector Q over here. The side Q, OB is Q. Now, let me take one perpendicular line from this, okay, and name this as D. I'm just taking a perpendicular line over there. Why? Because if I have to take a Pythagoras theorem, then I need a right angle triangle over here, right? That's the reason for that. I'm just taking one perpendicular line as CD. Now, let me name this now. Okay, since I can just tell over here, vector OA, the side OA will be vector P, right? Similarly, OB will be equal to vector Q and OC equals vector R. Okay, and then this I will take it as theta or something, and this I'll name it as alpha. Okay, I'm just taking it the angles over here. Now, I need to find the magnitude and direction of resultant of the vector. That means I need to find what is R. That's the reason I'll just take this triangle from triangle. Okay, students, from triangle COD, I'll take a triangle COD. So use a Pythagoras theorem. So what does it states? OC square equals OD square plus CD square. Okay, since OC is what? OC I have directly R, and OD is what? OD can be written as OA plus AD, and then we have CD square. Okay, so let me take this as equation 1 here. Why? Because I don't know what is OD and what is CD, right? So that's the reason I'll just take this equation over here. OC square as OD square plus CD square. Now, let me find out what is OD here. See, you can see this. OD can be written as OA plus AD, right? OA is vector P. But now, again, I don't know what is AD and I don't know what is CD. That's the reason what we will do is, we'll just take what is sine theta and cos theta from the triangle CAD. Okay, so from triangle CAD, what is sine theta? Can you tell me what is sine theta? It is nothing but opposite by hypotenuse, right? So opposite is CD, hypotenuse is AC or CA. I'll just take it as AC. Now, CD is what? CD can be written as AC times sine theta, whereas AC is what, students? If this is OB is Q, can we say AC is also vector Q because it's parallel? So that's the reason I'll just AC as Q sine theta. Okay, I got CD, I got the value of CD, CD as Q sine theta. Now, from the same triangle, let me take what is cos theta. Cos theta can be taken as what? Adjacent by hypotenuse, that is AC. So from here, AD equals AC cos theta. Now tell me what is AC? AC is again what? Q. So we can take this as vector Q cos theta. So finally I got what is CD and AD. Now it's all about substituting this in the equation 1. So now what is OC? You can see here OC is vector R square because it's a OC square. OD is what over here? OD is OA plus AD, right? I got AD as Q cos theta. You can just substitute this here as Q cos theta. Now, I need what? OD square. So, let me take a square of this. So, it is vector P. Oh, sorry. Vector P plus vector Q cos theta the whole square. So, that's a OD square, right? OD is P plus Q the cos theta the whole square plus CD square. So, what is CD here? It is Q sine theta. So, directly I'll take this as vector Q square sine square theta. Fine. Now, let me take this now. Vector R square can be written as, it is in the form of A plus B the whole square, right? So, you can just take it as A square plus this is B square plus 2AB, right? So, instead of A, I'll put P. Instead of B, I'll take it as Q cos theta. Plus, write this as it is. Q square sine square theta. Now you can see here, I'll just write this as vector P square plus, can I say this? Q square cos square theta and Q square sine square theta. Can I take a common of that? Can I take Q square as common? Yes, I can take Q square common. So what will I get here? If I take this common, I'll get cos square theta plus sine square theta. So remaining, you can write this as 2 P Q cos theta. Okay. Since I took this as common, I know that cos square theta plus sine square theta as 1. So directly you can take that as 1. Now you can write this as vector r square equals vector p square plus vector q square plus 2 vector p vector q cos theta. Therefore, the resultant, I need a resultant, right? I need the magnitude of the resultant vector. So what's the magnitude of a resultant vector? If I take square root on both the sides, I'll get vector r equals root of vector p square plus vector q square plus 2 vector p vector q cos. Hence, we proved this the resultant magnitude of resultant vector. Okay, so here they have asked us to find what is the magnitude and the direction of resultant of two vectors. So I have found the resultant of two vectors, that is vector p and vector q. Okay, and from this many MCQs are asked. So they might ask you at what point resultant is maximum, and I mean at what angle resultant is maximum, and at what angle the resultant is minimum. So what you will do, you'll just put the theta. In case if it is parallel, if they both are vectors are in parallel, then put theta as 0 degree. If they both are perpendicular, then you can take theta as 90 degree. If they are anti-parallel, then you can take theta as 180 degree. Then finally you will get the resultant. Okay, so I think that from there you can just take the conditions, those conditions, any one of the condition might be helpful for your, for the MCQ section. Okay, so this is all about the resultant. Now moving to the direction. Now I need to find out what angle the two vectors are placed, right? So I need to find out what is theta over here. What is the angle? So now what we can do here is we will just take the, let me take a triangle. 1 minute. Yeah, I'll take the same triangle. Okay. From triangle, again I'm come back to the triangle COD. Okay, I've taken a triangle COD. So from here, I'll just take what is tan alpha, because I can find what is alpha, right, using a tan. So let me take what is tan alpha. So what is tan alpha, students? Tan alpha can be taken as opposite by adjacent, right? So opposite is CD, adjacent is OD. Okay. Now, I've already found what is CD. Can you see here what is CD? CD equals vector Q sine theta, right? Similarly, what is OD? OD will be equal to vector P plus vector Q cos theta. Okay, that's it. Now, what is alpha? Alpha is nothing but direction. So, alpha can be taken as if tan moves to the other side, it becomes tan inverse of vector Q sine theta divided by vector P plus Q cos theta. That's it. So, this ends our derivation. Okay, so they asked us to find magnitude and the resultant of two vectors. Magnitude and direction of resultant of two vectors. So I found the magnitude as well as the direction. Okay. So now moving to the next question, show that the trajectory of a projectile is parabola. Okay, again, this is one of the most expected projectile motion question. So they can ask you, show that the projectile motion is parabola, or they might ask you what is the horizontal, maximum height, horizontal range, time of flight can be asked. So please remember this, and this is one of the most expected question. And remember all the formulas from this derivation, because from that formula, you might get the numericals based on the formula. Okay. So now let's move to the last derivation of this class. So it's a projectile motion. So let me draw two axes over here. Okay. So this is a projectile motion. So this is starts from the origin. Now I have thrown with some velocity u. Okay, it is thrown with some initial velocity u. That initial velocity can be resolved into two components. The horizontal component is always taken as u cos theta, and vertical component is taken as u sine theta. So this is a maximum height. So I need to find later, I'll be finding what is its height, and this is a range of the projectile motion. Okay, so now show that the trajectory of projectile. First, to show whether it's parabola or not, first let me check whether will it match a parabolic equation or not. Okay, so for that, let me take an equation of motion. S equals ut plus half at square. So let me take this equation of motion. So S is what? S is a distance, right? The distance now we have in x direction as well as in y direction. So for x direction, what is S? S can be taken as X. Okay, S is taken as X. And then U, what can we write? U in terms of X direction, U can be written as U cos theta. Okay, where acceleration or gravity is always 0 for a horizontal direction, right? So that's the reason I'm taking A or G as 0. Now substitute. If I substitute, I'll get X equals U. Instead of U, I'll take U cos theta into T plus, since G is 0, therefore this complete term will become 0. Okay, so I'll get X equals U cos theta into T, or from this I'll take what is T. T equals X divided by U cos theta. So this is, I'll take this as equation 1. Now, moving to the next term for Y direction. I'm taking both the direction over here, for X direction as well as for Y direction. So for Y direction, I will take S as Y. Now you can tell me, if I take S as Y, then what should I take for U? U should be taken as U sine theta, right? Because it's a Y direction. Similarly, A can be taken, it is going against the gravity, so I'll take it as A as minus G. Now substitute in the main equation, S is taken as Y equals U can be taken as U sine theta into T plus half. A will be replaced by minus G times T square. Okay. Now what we have to do is, since see from the equation, from this, I just took what is T, right? T is taken as X by U cos theta. Why? So that I can substitute that one, equation 1 in this. Okay, you can just mention this as, one second. Okay, I'll take this as equation 2. So substitute 1 in 2. Now, if I substitute, I'll get Y equals U sine theta. In place of T, put X by U cos theta. Okay, plus into minus minus half G. In place of T square, you can put X square by U square cos square theta. Okay, now I can cancel U and U. I'll get Y equals, what will be my equation? Y equals X sine theta by cos theta. Can we take sine theta by cos theta as tan theta? Yes, we can take it as tan theta minus G by 2 X square by U square cos square theta. Okay. So now this is my final equation of motion, students. Final equation. So now this equation will represent one of the general formula of this, that is y equals ax plus bx square. So this is a general equation for one particular shape. So that shape is nothing but what? Parabola. That's the reason we are saying that the trajectory of the trajectory of the projectile motion is parabola. Why? Because the final equation of motion is representing the what? Parabolic equation. Okay. So what is this parabolic equation? It is nothing but y equals ax plus bx square. Try to compare y with y. X is there, x is there. So what is a here? A will be equal to tan theta. Okay. Similarly, x square is there. Therefore, if I compare, I get b as minus g by 2 u square cos square theta. Okay. So that's the reason we say that the trajectory of projectile is parabola. Okay. So this is the expected 5-mark question, or they might ask you for a 3-mark also. Okay. Now, continuation of this, we have 3 things to derive. As I said, horizontal height, maximum range, and then we have a time of flight. Okay, so let's derive this very quickly. Now we'll use the same diagram for this, I mean the graph. Okay, so now I'll just take a same path over here. This is x direction, this is y direction, and the parabolic path. So it is represent u, and u is resolved into horizontal component as u cos theta, and this is u sin theta. Now, my first derivation is, what is the maximum height or a height of a projectile motion? H. So, to find the maximum height, okay, now let me take the next equation of motion, that is v square minus u square equals 2as. Okay, first I took s equals ut plus half at square. Now I'm taking the other equation of motion, that is v square minus u square equals 2as. Since it is height, think only in the vertical direction. Okay. So now, what will be the v, students? V can be taken as, what is the vertical, the velocity. Now we are thinking only about the height. So v is nothing but y direction. So v is nothing but taken as u sine theta. Okay. Whereas u is what? Initial velocity will be 0. And then a, it is going against the gravity, right? So a will be replaced by minus g, and s is nothing but height. So I'll directly take s as h. That's it. Now substitute everything in the equation of motion. In place of v square, take u square sine square theta minus u is 0 equals 2. A will be replaced by minus g, s is replaced by h. Oops, I'm so sorry. Final velocity is 0, right? One second. So here, so we are taking the equation v square minus u square by 2a, since it is a maximum height. So take only the vertical direction. Okay, it's a height we are talking about. That's the reason you look only at the y-axis. So now, for a height, v, final velocity will be 0, where initial velocity u will be taken as what? U sine theta. Okay, and a, it's going against the gravity, right? You are throwing an object. That's the reason a will be taken as minus g, and s is taken as h. Now substitute everything in the equation of motion. So v square can be taken as 0 minus u can be taken as u square sine square theta equals 2. A will be replaced by minus g, and s will be replaced by h. Okay, so you will get minus u square sine square theta equals minus 2gh. Cancel minus minus. What will be h now? H is taken as u square sine square theta by 2g. Okay, so this is a maximum height derivation. Okay, quite simple, right? Now, moving to the next. So next, let me take time of flight. Okay, so what's the time of flight throughout the projectile motion? I'll take it as t. Now, the next set of equation, that is, first I took s equals ut plus half at square. Next, I'm taking v square minus u square equals 2as. Now, the third, I'll be taking a very simple equation, that is v equals u plus at. Okay, so here time of flight, the time of ascent, that means going up and coming down we have, right? Time of ascent actually will be equal to time of descent. So let me take any one time, that is for a, what is that, vertical direction we are taking. Again here final velocity will be 0 and u is taken as what for a vertical direction? U sine theta, and a can be taken as minus g. So t can be directly written as time of ascent or time of descent. Okay, so substitute in the equation. So we get 0 equals u can be taken as u sine theta, a will be replaced by minus g into time of ascent. So from this I get time of ascent as u sine theta by g. As I said, time of ascent will be equal to time of descent. So same thing, you can write it as u sine theta by g. So now what is the total time of flight? Time of ascent plus time of descent. So whenever you add u sine theta by g plus u sine theta by g, you will get 2u sine theta by g. That's it. So this is time of flight derivation. Okay. So first we took horizontal, the maximum height. Then we are taking time of flight. Then the last equation you have is maximum range. Horizontal range. Okay. Horizontal range. Now I'm not taking any equation of motion. Directly I'll take. I need to find out what is a range. Range means what? Distance. As we know, distance is what? Distance can be taken as velocity into time, right? Since I'm taking horizontal range, that's the reason I will take the range as horizontal velocity into time of flight. So I'm taking it directly because we know that distance equals velocity into time. So here range will be equal to horizontal velocity into time of flight, you can take it. Okay, so what's the horizontal velocity? Horizontal velocity is u cos theta, whereas time of flight is 2u sine theta by g. Now, u can be taken as u square, 2 sine theta cos theta. Can we write it as sine 2 theta? Yes, divided by g. That's it. So, horizontal range is nothing but u square sine 2 theta by g. So this completes your derivation. I guess I've covered almost all the important derivations. It's not only for 5 mark. There are some which covers in 3 marker also. I hope you have understood this clearly. In case if you have any suggestions, please let us know. Drop your message in our comment box. Okay. Thank you for watching and all the best for your quarterly exam. Thank you.